Okay, for the second one, we have, okay, so you have to do basically the same type of problem. So you have to calculate the area between those two curves. And so you have the first curve is x equal to e to the y minus 3. And the other one is x equal to square root of y. And they say that you got to calculate this overlapping of areas when the x is between 0.5 and 1.5. Okay, first thing that comes to mind is watch out because this is your x. So they don't have the y equal to something and you're doing the x, right? This is x equal to something in the y variable, right? So basically what you need to do is to calculate for those x's, okay, how do the y's change, okay? So you can do, again, let's call this one 1 and this one 2. So for x1, okay, so let's work with the first function, okay? So when this is 0.5, okay, then you have for x1 equal to 0.5, how much is the y? So this will be the y1 minus 3, okay? And you will do this basically is your log of 0.5 equal to y1 minus 3. So this means that the log of 0.5 plus 3 is equal to y1. And when you do this, okay, you have log. So you have log of 0.5, and then you have this one plus 3, and you have a 2.31. So 2.31. Then you will do the same for the other x1, okay? So for 1.5, okay, and this is e to the y1 minus 3. So you do the log of 1.5 equal to y1 minus 3, and then you do the log of 1.5 what am I doing? Plus 3 equal to y1 still. So now you do the same things as before, and you will find, so this is log 1.5 plus 3, and you will find 3.41. So those are the two values for the first function, okay? Then let's focus on the second one. So for the second one, you have square root of 5. So you have square root of x, right? Oh my gosh, square root of y. Okay, so this is 0.5 equal to square root of y. Okay, so this means 0.5 squared is equal to y. So 0.5 squared is equal to 0.25. Okay, and then you have 1.5 equal to square root of y. So this means 1.5 squared equal to y, which is 1.5 squared, 2.25. Okay, so you have those other two values here. So now how do you decide everything? So when you draw your picture, okay, again, in my mind, you always should plot down the information there. So you have the first one, okay, which, so you have one of those that will go like this, okay, and then instead the other one, okay, will go like maybe this, okay. So now where are you calculating your region? Okay, you're calculating it right here. Okay, so basically you got to use the smallest point of intersection. Okay, so you got to go basically for those two. So those are smaller because 0.25 is um, is more obviously than the 231, and this one is smaller than this. So makes sense even if you don't plot it. Okay, you always want to find the smallest of those intervals, right? So at this point, what would you do? You will take the highest, right, minus the lowest. So obviously, and you know this is your, I don't know if you're allowed to use the calculator um, when you do the, but it's up to you when you do the practice. But anyway, you know that this one is your square root of y, obviously, because it's the one that never goes negative, right? And this one instead is your e to the y minus 3. So you will do the oh, I don't even know what you're looking at. Sorry. Okay, so at this point, it makes sense that your integral is the highest one, which is the square root of y, minus the lowest, which is this one, right? And you got to do it between the 0.25, okay, and the 2.25, okay. I'm pretty sure that you knew exactly what was going on, but I think you only chose, your mistake was choosing the integration limits, okay. So I think you should be good. Let me know if you need anything else or if I was clear enough, okay, and ask anything you want. Bye.